All right, 3-5, proofs with Cpctc. So let's talk about just a little bit of vocabulary here. So congruent triangles, that's what we've been working with. They're triangles in which corresponding sides and angles are congruent, meaning the ones that match up. So sides and angles are congruent. Okay, so when we've been doing our proof so far, we've been finding 3 congruencies, and once we find those 3 congruency statements, we can say the triangles are congruent. Well, sometimes the proofs go one step further and say that different parts are congruent. So we're still going to be doing the same thing where we prove the triangles congruent with our 3 statements, and then we have to go one step further. And the way we can go one step further is with what's called Cpctc, and here's what that stands for. Corresponding parts of congruent triangles are congruent. So basically, once we prove the triangles are congruent, we can say everything is congruent. So just because we mark 3 things, once we say the triangles are congruent, then the other 3 parts are also congruent. And this is known as Cpctc. So remember our magic number. How many congruencies does it take for us to show that 2 triangles are congruent? Well, there's 3. Well, remember there are 3 angles and 3 sides. So if we use 3, we know that there's 3 left to deduce, and that's how we can use our Cpctc. So let's practice with this first proof here. Remember, we always want to start with our picture, labeling our given, seeing which one of our 5 that we're using to prove, and then we'll go from there and look at our proof statement. Notice the proof statement is different from what we did the last few days. So we know in this first statement, bisect means to cut in half. So we're taking a line and we're cutting TRS in half. So if you need to see TRS, there's TRS. We're cutting it in half, meaning that angle 1 and angle 2 are congruent. So let's mark those. And that gives us our first letter of A. Next given says that angle 3 and angle 4 are congruent. So let's mark those. We need a double arc because it's a new angle. That's only 2. So where does our third thing come from? Do we have vertical angles or do we have a reflexive side? Well, RZ is a shared side, so that means we have a reflexive side. So we're going to use angle, side, angle to prove these 2 triangles congruent. Okay, so let's start with our proof here. Notice there's no blanks. You've got to know when to stop. So remember, our magic number is 3 here. So let's start with our first given, RZ bisects angle TRS, and that's given. But that's not a congruency statement, so that doesn't get a check mark. What did we mark congruent based on that bisector? We marked that angle 1 was congruent to angle 2 because the definition of an angle bisector. Okay, check, there's 1. Once we get a check mark, remember we go to our next given. Angle 3 is congruent to angle 4, and that was given. That's a congruency statement, so check, done there. So we've got our 2. Remember we said our third thing comes from our reflexive side. So RZ is congruent to RC. And we know that's congruent because of the reflexive property. Check, we have our 3 statements. So remember, once we get our 3 statements, we can now say the triangles are congruent. So let's say triangle TRZ, and this can kind of be your choice, what letter you want to start with. But if we start with T, then we have to start with S, so triangle SRZ. And we can say the 2 triangles are congruent because we used angle, side, angle to prove that. But look at your proof statement. It's not the triangle statement as it was in 3-4. So now that we said the triangles are congruent, we can say everything else is congruent. So we can say angle S is congruent to angle T because of Cpctc. And that's the only new part that we're adding to these proofs today. All right, let's go to the next one. So again, let's start with our picture. M is the midpoint of AD. Remember, M cuts a segment in half. So we know that the distance from A to M is the same from M to B or B to M, depending on how that's set up. So that gives us an S. Then it tells us that angle 1 is congruent to angle 2. Okay, so they have been reflected. That gives us an A. And then angle 3 and angle 4 are congruent. That gives us all three pieces, so we don't have to worry about reflexive or vertical angles. So let's start with our first given. M is the midpoint of AB. You can abbreviate midpoint, that's okay. Now that doesn't get a check mark. We have to get a congruency statement from that given. So remember, when we mark that, we said that AM was congruent to BM because of the definition of a midpoint. And if you need to highlight that to remind yourself, go for it. Okay, that's a congruency statement, check. So once we get a check, we move to our next given. Angle 1 is congruent to angle 2. That was given. That's a congruency statement, check. Moving on to the next given. Angle 3 is congruent to angle 4. That was given. There's our 3 check marks. Remember, what follows after the check marks is our triangle statement. So triangle, let's say ACM is congruent to, and if we start with A, we have to start with B, B, D, M, and we prove that with angle, side, angle. Now look at your proof statement. It wasn't a triangle statement. So again, now that we said the triangles are congruent, we can say everything is congruent. So we can now say that AC is congruent to BD because of Cpctc. Okay, last example here. We have given that side AB is parallel to ED. Remember, we talked a lot about parallel lines, and if we have parallel lines, it doesn't mean congruent sides. It means that we have those alternate interior angles, so we have to think about that. So let's highlight A to B and E to D. We know that if we have those parallel lines, this could be a transversal, and if that's a transversal, then we know that these two angles are congruent. We could also use line AE as a transversal, okay, same parallel lines, which means that A and E are congruent. So there's an A and there's another A. It also says that C is the midpoint of BD. Well, if C is the midpoint, that means the length from B to C is the same as D to C, and so there's our S. Now, remember we struggled between looking at angle, angle, side, and angle, side, angle. Well, ask yourself, is the side between the two angles or not between? Well, we can see that it's not between, so that means it's angle, angle, side. We're not using angle, side, angle. All right, let's start with our proof. We were given that AB was parallel to ED. That does not get a check mark because that is not a congruency statement. The first thing we marked that angle B was congruent to angle D because they were alternate interiors. We also marked that angle A was congruent to angle E. Those were also alternate interior angles. Okay, both those are congruency statements, so let's put checks beside them. Now, I know that you could have used the vertical angles here also, but if we have those alternate angles, let's just go ahead and use them and then say vertical angles if we need something else. So then we go to our next given. C is the midpoint of BD. That does not get a check mark because that's not a congruency statement, but we did mark that side BC was congruent to side DC because of the definition of a midpoint. There's our third check. So remember, once we get our 3 checks, we can say the triangles are congruent. And I'm going to run out of room, so write small here. So we can say triangle, let's say just triangle ABC. And if we start with A, we've got to start with E, so we can say EDC. And we used angle, angle, side to prove. Now, look at your proof statement. It's not the triangle statement, and it's not a congruency statement. So we kind of have to work our way to this one because it's just saying that C is the midpoint of AD. Well, that doesn't tell me parts are congruent, so that's not a Cpctc statement. We have to get that statement. So if C is the midpoint of also AE, then we know that AC and EC are congruent. So let's write that out. Again, we have to write small. And we can say that's congruent because of Cpctc, because if the triangles are congruent, then all the parts are congruent. And now we can say that C is the midpoint of AE. So we kind of had to work this one backwards a little bit because of the definition of a midpoint. We had to use that proof statement to get the Cpctc statement. So what I'm saying here is we had to get this statement here from our proof. Okay, there was no way to do that without the proof. So your Cpctc statement must be a congruency statement because that's what a bunch of those C's stand for. Corresponding parts of congruent triangles are congruent. So we have to use Cpctc with a congruency statement. So just pay attention to who your proof statement is. If it's a congruency statement like the first two, we just finished with Cpctc. If it's